Hi everybody, welcome back to Spratt Stem Academy. Today is Saturday, so you know what that means. It is SAT Saturday. This is the SAT Saturday video number 2, and this is a continuation from SAT Saturday number 1 video. I'm using the SAT Practice Exam 10 from the official College Board website, and these are problems 4 through 7. So we're going to be going through these problems together, walking you through some SAT tips, and just talking about the concepts for each problem. So let's start with number 4. Remember, the first thing you want to do is really read the problem and then write your goal. That way you know exactly what you need to do and look for. So we have a graph here. Let's also read the passage that they give us. The line in the xy plane above represents the relationship between the height, h of x, in feet, and the base diameter, x, in feet, for cylindrical Doric columns in ancient Greek architecture. How much greater is the height of a Doric column that has a base diameter of 5 feet than the height of a Doric column that has a base diameter of 2 feet? So the first thing we want to do is we've read this huge passage, but we just want to know what the important information is. We know that we have an XY graph plane, and we know that height is h of x, which is also, they're telling us in the graph that that just means y. So I'm going to highlight the y-axis because these numbers on this side are giving us height, and I'm going to label that. They also tell us that x, and I'm going to use a different color, the base diameter is x. They tell us this in the problem right here. So I'm going to label this axis as diameter. Okay, and then if we look at the main question stem, how much greater is the height of a Doric column that has a base diameter of 5 feet than the height of a Doric column that has a base diameter of 2 feet? So our goal is to find a difference. So I'm going to write find difference in height. And I'm also going to say that I know that height is y. Okay, so let's go back to the information they told us. We know that the height of a Doric column that has a base diameter of 5 feet. So we know that base diameter is represented by x values and height is represented by y values. So since we're dealing with a linear pattern here, I'm just going to use coordinates to write out our data. So they say that one Doric column has a base diameter of 5 feet, and if 5 is represented by x, and remember that we write x, y coordinates like this, I'm going to write 5, and then for our other column, I'm going to write 2 because it has a base diameter of 2 feet. Now, looking at the graph, what I'm going to do is I'm going to start with this point here. I'm going to go to 5 on the x-axis, and how I'm going to find the height for a column that has a base diameter of 5 feet is I'm going to go up, up, up until I'm touching the line from where my x value is. And so the value when x is 5, the value of y is 35. So the height of the column with the base diameter of 5 feet is 35. And I'm going to do the same thing for the next value. Actually, I'll just leave this here. So now I have to start at the value of 2. I'm going to go up, up, up until I'm touching the linear function line, which is going to be here. And at the value of 2 for x, my y value is 14, which means a column with a base diameter of 2 feet has a height of 14 feet. And so we have some data. Now we want to know the difference in height. So in order to find the difference in height, all we have to do is take the value of 35, the value of 14, and they ask us for a difference, which implies that we're going to subtract the values. So it's going to be 35 minus 14, which is 21. And as you can see, we do have an answer choice for 21 feet. So that is how you answer question 4. Let's move to question 5, which won't take very long. Question 5 states, if x is greater than 0, which of the following is equivalent to the given expression? So our given expression is the square root of 9x squared. And let's write down our goal quickly. Our goal is to simplify. So we're just wanting this to be simplified and hoping that whatever we simplify this to gives us one of these options. So we know we have 9x squared. The first thing you can do in simplifying this is you can actually split this apart. So we know we have the square root of 9x squared. If you look at 9x squared, you know that this is just 9 times x squared. So I'm going to just separate the square root into 9. So I'm going to write the square root of 9, and then also the square root of x squared. If we simplify this further, what is the square root of 9? The square root of 9 is 3 multiplied, and that's going to be multiplied by the square root of x squared. But we're not quite finished yet. We can actually simplify the square root of x squared. And if you think about it, think about what x squared means. X squared is just x times x. And you know that when you're squaring something, it just means that it's a number multiplied by itself. So we can simply rewrite this as just x because it is squared, and so it's simplified to just x. So we now know that we have 3 times x, which is just 3x. And if we look at our answer choices, we see that A is in fact 3x. So that's question number 5. Now let's look at question 6. What are all values of x that satisfy the equation above? So here we have an equation. Our goal, once again, is to simplify. So we're going to simplify, and I'm going to add an extra step. We want to simplify and find values of x. So we're not just going to simplify. We have an equation that has variables on top, variables on the bottom. What we're going to do to make this easier is I'm actually going to bring this x over 1 to this side of the equation. So all we have to do for that is simply multiply x minus 1 on this side, and then also multiply it on this side. So if we have x minus 1 on the top and an x minus 1 on the bottom, these will cancel out. So we'll just be left with x squared minus 1 on the left side of the equal sign. But on the right side, we have negative 2 times x minus 1. And in order to simplify this expression, all we have to do is distribute the negative 2 to each term. So let's rewrite this so that it's a little bit cleaner. So we have x squared minus 1 because we canceled out our x minus 1 on the bottom by multiplying it by x minus 1. And we have negative 2x because we're distributing the negative 2 times x. And then we also have to distribute negative 2 times negative 1, which is positive 2. So don't let that confuse you. This is not negative 2, it's positive because 2 negative numbers multiplied together makes a positive number. Okay, so now we have x squared minus 1 equals negative 2x plus 2. The best thing to do when you're dealing with a quadratic equation or quadratic function and you're wanting to find values of x, the best thing to do is to get everything on one side of the equal side and have the equation equal 0. So let's do that. So here I've written out that we've added 2x on the left side. I'm also going to bring over this 2 by subtracting it since it's positive here. And then we're going to have a negative 2 on the left side as well. So we have negative 1 minus 2 equals 0. Simplify this even further will give us x squared plus 2x minus 3 equals 0. We're left with this quadratic equation, but we need to find the solutions to this quadratic equation. And so we have to factor this expression. So the best way to factor is make two parenthetical spaces. And essentially what you want to do is look at this number. So this number is going to be the one that doesn't have a variable. And you want to ask yourself, what two numbers multiply to make this number, but also add together to make this number? Do they also add together to make this number? So if we think about what we multiply to make 3, we think of 3 and 1. 3 times 1 is 3, right? We can also manipulate this to give us that 3 minus 1 is positive 2. So I know this sounds a bit confusing, but just stick with me here. We're going to add an x to the parentheticals. And for now, I'm just going to write negative 3 minus 1. If you were to distribute this quadratic equation, you would get x squared, because we're using the FOIL method. So it would be x squared minus x minus 3x plus 3. And that would give us x squared minus 4x plus 3. Is this the same as our equation above? No, it's not the same. So that means that we did not factor our numbers correctly. So we want to figure out whether or how we can make the signs on these numbers make negative 3 and positive 2 if they were to be added or subtracted. So negative 3 times negative 1 makes positive 3, but we want negative 3. So one of these has to be positive. Let's make the 3 positive 3. If we multiply these together, we have 3 times negative 1. That will give us negative 3. If we also take 3 minus 1, it'll give us 2. And this does, in fact, give us the correct factoring for this problem. So we now have these parenthetical expressions. Now we use these and set them both equal to 0. And those will give us the x values that satisfy the original equation. So x plus 3 equals 0. That gives us that x equals negative 3. X minus 1 is 0. That gives us that x is equal to 1. So our solutions are negative 3 and 1. But here's the thing about the SAT. They're going to make you think that you're done at this step. But before you say that you're done, it's really, really important that when they give you a problem like this, you plug your values back into the original equation to double check that they do satisfy the equation. So let's start with negative 3. If we were to plug in negative 3 into the equation, we would get negative 3 squared minus 1 over negative 3 minus 1 equals negative 2. Let's simplify this side to see if it'll give us negative 2. Negative 3 squared is 9 minus 1 over negative 4, which is 8 over negative 4, which is negative 2. And negative 2 does in fact equal negative 2. So negative 3 is a solution, or a value that satisfies the equation. Let's also plug in 1. 1 squared minus 1 over 1 minus 1. Will that give us negative 2? Let's check. 1 minus 1 over 1 minus 1 is 0. And 0 does not equal negative 2. So even though that's what we solved for, 1 does not satisfy the equation. So the correct answer is going to be A. So that's question number 6. For the last question, let's read the problem. The graph of y equals f of x is shown in the xy plane. What is the value of f of 0? So for these kind of problems, they require almost no math. All you need to know is how to read an axis on a graph. So our goal here is to find value on graph. So that's all we're doing. So we know that y equals f of x. So all you have to do for these type of problems is whatever number they give you for the x, so in this case it's 0, you're going to find that number on the graph, so your x value is 0, and simply ask yourself, when x equals 0, what is y? That's all that this means. So whenever x equals 0, what is y? So all you're doing is finding your y value for when x equals 0. You can also think of it as finding the other coordinate. So if we go up, 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 we want to know when x touches the function, which is given by this. And when we finally are touching the function, we are at the point 4. So when x equals 0, y equals 4, which means that f of 0 is 4. And this is stated in answer choice D. And that is how you solve number 7. That is it for this video. We've gone through 4 SAT problems. I hope this helped, and I hope you all learned something that'll help you with your practice for the SAT exam. Best of luck, great job, and I will see you all in the next video. Thank you for watching. Don't forget to subscribe and follow for more.